Hello, everyone. I'm Professor John Nguyen, and welcome to Chemistry. In this video, I would like to take the chance to go over quickly the homework for Chapter 4, Chapter 5, and Chapter 6. I believe it's in another video during the lecture for Chapter 6, we already went over Chapter 6 homeworks. All right, but it's definitely beneficial to take a look at them again. And that's actually the secret. When you study something, always good to look over them again. It's the first time you read something or you do something, we tend to miss a little detail. Okay. All right. And this homework give you a good overview of what you need to know for the three chapter 4, 5, 6 for the next exam. All right. Here's chapter 4. The first foundation skill is to be able to convert rams of a substance to moles. Convert ram to moles or moles to rams. Okay, so for example, if we're given 4.5 rams of sodium hydroxide compound to moles, all right, it's like you're given 24 eggs and ask you to convert to how many dozens? Kind of like that. Okay, so we need a conversion factor. And that would be, for this particular one, it would be molar mass. For a dozen, 1 dozen equal to 12 eggs, okay? But this one is going to be molar mass. So that's what we have to do first. We need to calculate molar mass of sodium hydroxide. And that will be sodium plus oxygen plus hydrogens. You look up on the periodic table, you can see hydrogens, sodium is 22.99, oxygen 16, and hydrogen is 1.01. So here we go. We add them all up. It should be right on 40.00. For molar mass, I usually keep 2 decimal places. That way we have plenty of significant figures. All right. So, but notice that 4.50 is given to us in 3 significant figures. So when you take 4.5 rams, remember we have to cancel some, okay? And that's ram. So if you put moles on the bottom, that would not work, okay? With moles on the top, that's the units we're going to keep. So 4.50 divided by 40 times 1 is the same. Gram cancel out. We got 0.1125 moles. That's what it shows in the calculator. But because we've got to be consistent with significant figures, we should round it up to 0.113 moles. Same as in given quantity. Okay, 4.50, 3 sit fit. Okay, that's the first one. Now, 24.6 gram of oxygens. If you know the method, you can do any conversion you want. You don't have to memorize it. Now, what we need is molar mass and set it up correctly, the ratio. Okay, molar mass is mass equal to 1 mole. For oxygen, look it up 16. We did it before, 16 times 2 because it's O2. Oxygen gas is O2, 32 gram per mole. Okay, now we can't do gram per mole because we start out with ram. So ram has to be in the bottom denominators. So that means 1 mole, if there's no number 1, meaning it's 1. On top, 32.00 ram denominator to cancel out the ram, but you don't cancel out the numbers, obviously, because they're not the same. So you take 24.6 divided by 32, use a calculator, you get 0.769. Round it off if you need to. 3 significant figures. When you're not sure, check the given numbers. That's 3 sit fit. We gotta have 3 sit fit. Okay, now it's the reverse conversions. We're going from 1.5 moles of CO2 to rams. We still need molar mass. CO2, we got 1 carbon, 12.01, plus 2 oxygens, 2 times 16. That should add up to 44.01 gram per mole. Now this time we're going to use it as is because we want to keep the ram on the top and moles on the bottom. There's no number, it means 1. When you put 1, it doesn't change anything, especially for multiplying and dividing. So 1.5 mole times 44.01 divided by 1, we should get about 66 gram if we round it off. Again, that's 3 significant figures. That's pretty standard. Okay, and here's another one. So we got 2 practices for converting ram to mole and 2 practice exercises for mole to ram. 1.20 moles of water. Molar mass of water, 2 hydrogens plus 1 oxygen, should be 18.02. 1.20 moles of water. Now this time we use as is, 18.02 gram over 1 mole. Mole cancel out, multiply them together, 1.20 times 18.02, we should get 21.6 grams. Okay, so that's first homework problem is great. So go look over them again and try for yourself before you look at the answer. Be able to convert gram to moles, mole to gram for any substance, any compounds, including elements. If you convert how many such and such, like 10 grams of carbon to mole, then you just have to look up carbon. Okay, so elements, it will be 12.01. Okay, so element does exist by itself, doesn't have to combine with or bond with other elements to form compounds, and we can do that conversion too. All right, the second major concept is about chemical reaction equations, and we need to be able to balance the chemical equations, break aqueous compound into ions, and then cancel out a spectator or common ions, and to achieve the net ionic equations. And here it is. Okay, so let's say we have sodium carbonate aqueous, means soluble in water, plus barium chloride aqueous, also soluble in water. Now swap the ion. Sodiums want to go with chloride, and because sodium is +1 and chloride is -1, you can look at the handout and for the ions, you see them in there. It's actually also on the periodic table right here. I label +1 for the whole columns. Sodium is on the first one, alkali metals, +1. Chloride is on the column or group 17, that's -1. Like all of them up to iodide. All right. Now, so back to this, sodium is +1, chloride is -1. So they're perfect together. There's no need to write 2 and 2 subscript. However, kind of like factoring out, we put the 2 there. And that's actually part of balancing equations. We want to make sure we got 2 sodium here on the left side, reaction side, we got 2 sodium on the right side. When I think about this number 2, the coefficient is, it goes for sodium, also goes for chloride, go for every single element in that compound. And if that element has already have a subscript, you have to multiply by that subscript. All right, the other one's barium. Barium is a cation, it's +2, it has to go first. If you go back to the periodic table, you see barium's on the second group or second column. It's barium is right here, number 56. Okay, so +2 -2 perfectly together. Now you look at into the solubility rule, see the solubility rule. Okay, in the study guide, you will see barium carbonate is insoluble. So we have to label S, means solid. It's right here. AQ means soluble in water, aqueous. S means insoluble or slightly soluble, meaning solid. Okay, now it's time to break them. That's called molecular equations and its balance. Now it's time to break the only aqueous compound into ion. No solid, no gas, no liquid. Those stay the same. Okay? Because they are not ionic compounds. Okay, so only ionic compounds. I'm sorry, because they're not soluble. They cannot be separated. Okay, they're solid. Now, sodium, you got two sodium, but we have to write 2 as a coefficient, sodium plus. Carbonate plus barium plus 2 chloride. Over here, we got 2 sodium and 2 chloride minus plus barium carbonate stay the same. Don't break solid compound into ions. Okay. Now, if you got 2 sodium plus on the left and 2 sodium plus on the right, that's the same. So you can cancel out mathematically. Okay. Those are called spectator ions or common ions. They show up both on the left and on the right. Another ion we can cancel out that would be chloride. So we're left with barium 2 plus and carbonate. We always want to write barium 2 plus first when you combine them together, because the cations got to go first. Okay, and this equation is very precise. It tells us exactly what happened. Barium combined with carbonate to form barium carbonate, which is an insoluble compound, a precipitate. Sodium and chloride are floating around the solutions. All right, they don't stick together. Sounds good. Okay, now here's more equation for us to balance and also classify, meaning what type of reactions. In this case, I must have forgotten to mention what type of reactions. Now we got magnesium react with FeCl3, that iron Roman number 3 chloride, switch magnesium combined with chloride, and that's subscript has to be readjusted. Okay, because Fe is 3 plus in this case, but when it goes with magnesium is only plus 2, so you only need 2 chloride. Fe by itself. Okay, now that's what the job of the balancing equations. After you're done, you go 1 magnesium, that's good. 1 Fe is good, but the problem is with chloride. We have 3 over here and we got 2 over here. And the only way to make them equal is to multiply by 2 on one side and 3 on the other side to get 6. That's the lowest common multiple. Okay. When you multiply this by 2, you multiply it by 3, you end up with 6. 2 times 3 is 6 chloride. 3 times 2, that's 6 chloride. Now you just have to adjust to balance the Fe and magnesium, and we're done. 2 Fe is no big deal. 2 Fe, number 2 there. 3 magnesium, put number 3 there. Because the single one is really easy to keep them equal. Okay, on here, everything's perfect. 1 carbon, 2 oxygen plus 1 here, that's 3. 2 hydrogens. When everything's perfect, we don't have to put any numbers. No numbers mean 1. That's why I put 1 there. Okay. But you don't have to. We assume it's 1. It's there automatically. And the third one, we have KOH react with H3PO4 and to give us potassium phosphate plus water. Now, we got 3K because K is plus 1 and phosphate is minus 3. That's why. So we did not make up that subscript, okay, because of the charge. Now that's 3K means we need 3K over here, number 3, because we cannot change the subscript. We put the 3. And that's go for OH2, okay. So that make it a 3 oxygen here and 3 hydrogen. So that's why plus 3 here, that's 6 hydrogen total. So that's why we have to put the 3 here to multiply it by 2 to make 6 hydrogens. And now if you check oxygen, it's perfect. 4 here and 4 here, 3 oxygen here, 3 here, perfect, right? So the balance equation is not, it's not hard. You just have to play around with the numbers, somewhere between 2 to 10, that's going to work. Sometimes you do have to go over 10. Most of the time, that's for organic chemical reactions, but for regular reaction, inorganic, the general one, somewhere between 2 to 10, those are coefficients will work. All right, now to classify the reactions, the first one, because we have a single element right here, Mg, we call this a single displacement reactions. It's very simple, okay? When you got two compounds, CO2 and water combine together to form one, that's called combinations. When you have an acid, which is H3PO4, react with a base, and by the way, there's no number there, it means one, okay? Acid react with a base, we call this a neutralization reactions. So please take a note of that. Single replacement, combinations, neutralization reactions. Okay? All right. Now, that's the second major part of concept and skill of chapter 4. And then the last important part of chapter 4 is the stoichiometry or chemical calculations. Now, there are two things that we need for chemical calculations. First one is the balance equations. The second one is the molar mass. Okay, if we're not given moles of a substance, whether it's a reactant or products, if we're given gram, we have to convert it to mole. All right. Well, first of all, this is a given equation that's not balanced. And so here we go. After playing around with the numbers, counting the nitrogens, I think hydrogen is a problem. This one is actually tricky. 3 hydrogen here and 2 here. So you would multiply this by 2 and multiply this by 3, but end up doesn't work out with the nitrogen, so that's why we double it. So we multiply this by 4 to get 12 hydrogens, and we multiply this by 6 to get 12 hydrogen as well. And that works pretty well. And that's 4 nitrogens, so we put 4 nitrogens. And then if you add up oxygen on the right, it's 6 right here and 4 right here, make it 10. So you multiply it by 5 here to make it 10. Okay, so that's a little tricky, but we got it, right? Like I said, pick one element like hydrogen and try to balance first. And if it doesn't work out, just double it, make it 6. Doesn't work, make it 12. 12 doesn't work, make it 18 or make it 24. It will work if you keep going up like that. But don't go too much, just enough to make it work. Okay, so the question asks how many moles of NO, nitrogen monoxides, are formed when 12 moles of oxygen gas react completely. Okay, we're given moles of oxygen gas. That's good. So mole is ready to go. We don't have to convert it to mole anymore. Sometimes we convert mole to gram and gram can convert back to moles. We don't need to do that. Okay, 12 moles. Where do we get this ratio? Okay, well, every 4 moles of NO is formed from 5 moles of oxygen. Those coefficients are in moles. 4 moles, 5 moles, 4 moles of NO, 6 moles of water. Okay, that's what it means on the balance equation. And they're so important. If we get those wrong, we're not going to get this one right. Okay, so you get this ratio from the balance equations above. 4 moles right here over 5 moles of oxygen. Remember, we always have to cancel out something. Moles, oxygen cancel out. Take 12 times 4 divided by 5, which gets 9.60 moles of NO. Now, how come this guy only have, one sit fit? No, they are exact numbers. They actually have unlimited. The best way, just based on what's given. 12.0 has 3 sit fit. Final answer, 3 sit fit. Significant figures, and we good. All right. Now, for part C, um, we're given grams of ammonia, and we asked to calculate grams of NO. Well, that's going to be extra steps. The first thing you want to do is convert to mole first. And again, we've done this. Okay, at the beginning, we need molar mass right here. Convert it to mole, and then we set up the ratio. Remember 4/4. Got that from balance equation above in part A, right here. This is like a guidance, like a recipe for the calculations. And then after you get that, that's the molar mass. 30.01 gram per mole, that's molar mass of NO. Okay, so that way you can cancel out the mole and get the grams. And right here, I have the calculation for molar mass. Remember, we need molar masses. We need balance equation, which we already have here in part A. Okay. All right. So that's how you set it up. You have to get the mole first. D is another similar situation when we got the 15 gram of water and how many gram of oxygens. We can set this all up in one step, one multi-step calculations. Okay, multi-step chemical calculations, stoichiometry. So we start out 15 grams of water. First step, 1 moles of water over 18 grams. That's molar mass of water. Convert it to mole. Set up the ratio, 5 moles of oxygen over 6 moles of water. Where do we get that? Right here, 5 moles of oxygens over 6 moles of water. Okay, from the balance equation again. And then finally, 32 grams of oxygens over 1 mole. So that way you can cancel out a mole and you end up with 22.2 grams of oxygens. All right, everyone. That's it for Chapter 4. Those are major concept and skill. Those are the key concept and skill for Chapter 4. And so you have time, go over them again. Practice. That'll be good to answer a lot of, about 10, maybe 10, 12 questions on the exam. Well, thank you everyone for watching, and in the next video we will finish the rest of them. Or it's very clear. You can just go over them and practice and then check the answer. Okay? Well, thank you for watching, everyone, and see you next time. Have a good day.